All right, thank you everyone. Hello. So my name is Nathan Mars, and I'm a software engineer at Grafana Labs, and I'm based out of Monterey, California. So today we're going to be talking about the intersection of observability and AI, and how Grafana has approached this topic. So our journey begins. I want this material to be as accessible as possible to everyone, so I want to begin with some baseline information. First, what is observability, and what problems are we trying to solve with this? There's many different ways to define observability, and this quote from Grafana's Director of Community sums it up nicely. It's about enabling humans to understand complex systems. And we need to understand them, because we need to operate them. So what does it take for humans to understand complex systems? I will go over two different aspects. The first is deep domain knowledge. You need to understand how your system works and how its dependencies work and where its boundaries are. This is not easy. As new technologies emerge, the modern stack is getting more and more complex, and there's more and more layers of abstraction. It's not just knowing your service, but also keeping up with this new tech. Another consideration is that there's more data than ever before. And we've said the word data a lot today, so I'll try to not say it too much in this presentation. There's more metrics, logs, traces, and profiles, and this can lead to an information overload. And even if you have this deep domain knowledge, we're in a team sport here. You have to kind of deal with people leaving and people joining the team and ensuring that that context remains steady across the lifecycle of teams. Next, we have toil, which is not just work I don't like to do. It's work that's fundamental to running a healthy service. And this scales as a service grows. This tends to be repetitive and reactive, things like restarting a stuck Kubernetes pod or scaling up your deployment. And these are manual tasks that can take up a lot of time. Things like building dashboards, configuring alert rules, writing post-incident reviews, etc. So in practice, this is what observability kind of looks like. You have your core pillars of data that you're collecting, like metrics, logs, traces, and profiles. You have various workflows that draw from that, such as on-call, incident management, SLOs, alerting. So the question here is, what's the role of machine learning and AI in all of this? So we've defined the role as minimizing both toil and the need for deep domain knowledge, enabling us to understand complex systems more efficiently and effectively. So we want to use AI and ML as tools to help us make things less complicated, with the key point here that we still want the human to be the driver. We're not wanting machines to take over all this work. So before we jump into how specifically Grafana has approached AI and ML, it might be good to also understand what Grafana is. So first, a quick poll. Raise your hand if you used Grafana before and know what it is. All right, that's pretty good. Sweet. Just a quick run through. So Grafana, for people that may not know what Grafana is a leading open source platform for monitoring observability. It was developed in 2013 by Tolkien Orderguard and is now maintained by Grafana Labs. And Grafana's mission is to make it easy for everyone to understand and monitor their data. Grafana's core strategy, right, is kind of having this big tent philosophy, supporting as many data sources as possible, which eliminates vendor lock-in. This big tent kind of empowers our users to query, visualize, and alert on and understand their data no matter where it's stored. With Grafana, you can create let me reset that. With Grafana, you can create, explore, and share all of your data through beautiful and flexible dashboards. And Grafana is used by organizations of all sizes to track their performance, identify problems, and make informed decisions. It's a powerful tool that can help you improve your efficiency and productivity. This is something I'm very excited about. In addition to its commercial use, Grafana is also very popular with hobbyists. So many people use Grafana for a wide variety of use cases, from monitoring their home solar power, tracking metrics from their IoT smart devices, or even creating a daily commute assistant dashboard, which is what this is. In this example, the dashboard is drawing from APIs, such as a GTFS real-time feed to pull in data from weather.gov, the Metropolitan Atlanta Transit Authority, drive time information from Google Maps and Bing Maps. So if you're ever wondering if Bing Maps has a map service and someone uses it, you found your answer. I did not know they had one. So Grafana's flexibility and ease of use makes it a great choice for hobbyists who want to have deeper insights into their data without real limitations. And we've seen it used in the wild for a myriad of use cases, from monitoring popcorn levels at a theme park to helping Japan land on the moon, although not successfully, but that's okay. It's a thought that counts. So great. Now that we have an understanding of observability and what Grafana is, we can dive into how we've approached AI. And we'll start with the more classic machine learning feature. We're going to take a look at adaptive telemetry. As I mentioned before, one second. This feature leverages classic machine learning and data processing and does not use generative AI. Adaptive telemetry evaluates which telemetry signals to keep and which ones to aggregate or discard. These features make recommendations for how to reduce or simplify data and refresh those recommendations over time. Humans can kind of come into this process and set up exceptions to these recommendations that are being generated. So looking up here at the top left at adaptive metrics, this is where you can aggregate and keep the same shape of the metric without having to keep everything, basically like lowering the resolution, but only keeping the most important bits of that event. So based on metric metadata and how they're queried, we can kind of see what signals are just kind of the default signals being collected by the monitoring system, and just drop those. And then we have adaptive logs here on the top right, which we're going to talk a little bit more into. This uses a drain algorithm to extract patterns and also review what logs are queried to come up with recommendations on which ones to keep, which ones to drop. So let's take a little bit closer look at adaptive logs. Zooming out a bit here, like what are logs, right? Here are some example logs. Logs are event-driven and provide context on your system's health at a given point in time. The problem is a lot of logs are just noise, and they don't really add any value or give you any value. And on top of this, they can be very costly to persist at large scale. So what if there's a way to only persist the important logs? This is where adaptive logs comes into play. So under the hood, adaptive logs uses machine learning to perform large-scale telemetry analysis. What does that actually mean? We first send all incoming logs to a pattern miner service that uses a drain algorithm to extract patterns. You can think of a drain algorithm as a specialized way to sort jumbled information into patterns. Using like a very basic example here, right? Imagine you have like a big Lego set and you want to organize all the pieces in the different shapes and sizes. A drain algorithm is like a special robot that helps you pick up the Lego pieces and sort them into groups based on how they look. So it's really good at picking out patterns and finding the places, finding all the pieces that have the same shape and color. So this results in us generating patterns from the logs and knowing which patterns are responsible for the highest volumes of logs. Just to note, this does require a fair bit of fine-tuning to actually get useful patterns, but we're not going to dive into that. So now on the read path, when you're actually trying to access these logs, we count how many times each pattern is returned in your query results. For this, we leverage a technique known as like reservoir sampling, since it's otherwise infeasible to increment a counter for every single log line returned. This counts the actual log lines returned in your query and not the log scanned. So it's counting the log lines that would actually be returned. With this, it gives us a picture of what comes in and what gets queried, which is what we can then use to get a basis of recommendations on which logs to drop, which ones to keep. So we see here on the bottom example, if it's rarely queried, we'll drop most of the lines. And here on the top example, if it's often queried, we'll keep all the lines. So our early customers are actually getting pretty good value out of this, like reducing their log volumes by 10 to 60%, which is pretty wide. And internally at Grafana, we've seen a reduction of 40% of log lines ingested, which means we're not having to store them and pay for that storage. Sweet. So overall, the adaptive telemetry feature has delivered value. It does face some challenges, though, especially with adaptive logs. The main question here is, like, how do we prevent false positives or not dropping important information that we need? Just to note, the data processing and machine learning side of this feature was only a small part of the work. Think of like an iceberg, right? Only the top bit. A lot of the work for this feature was figuring out how to handle the UX of letting humans control the process of these recommendations. And there's two user workflows critical to this feature. The first one is how to enable these rules confidently. being able to apply very clear recommendations, allow exceptions, and being very careful of auto-apply, because you don't want to drop important information that could have saved the day. The other is the pain point of actually setting up the monitoring in the first place. So setting up collectors and agents, a lot of times you'll get basic defaults from these, and you'll get a lot of extra data that you don't want to store and don't need. So the question is, do we kind of force people to sanitize that themselves, or we just accept the need for more expensive storage and this type of solution? Because the best solution, right, would be just don't send the data in the first place. All right, so we've reached into the unknown of large language models. We kind of see these closing the gap in two different areas. The first is you know what you want to do, but you don't know how to do it. Example of this is writing a SQL query. Or the second example here is you know how to do it, but it takes a lot of effort. So that's like summarizing a document. I think something to point out here is that a lot of the power of large language models is that you can use natural language as the interface, making this a lot more accessible to everyone, not just people that know how to code. These two gaps actually map pretty nicely to the two challenges of observability that we kind of talked about before. And what this represents is a big and exciting opportunity in the space. We've kind of been given this ChatGPT hammer, and it's a bit of a choose your own adventure. Like, what nails can we hit? It can be a fickle hammer, though. Sometimes it's great, sometimes it's not. It can be unreliable, hallucinate, and just flat out make things up. But in some cases, we've actually found we've been able to knock some sense into the hammer. And as we've learned more about this tool, we realize more of the value that we can gain from it. So much so that we've actually built a plugin for working with Grafana to build with GenAI features. So you can actually build GenAI support directly into Grafana open source now, and anyone can add a generative AI feature into Grafana. We have this centralized LLM plugin where you can opt into these features that we're building and kind of manage and customize the use of these features, like changing a model from OpenAI right to Google's model, whatever. So let's actually look at 3 different GenAI features that we've developed. So the first is a dashboard assistant, which is pretty close to my heart as I helped build this out as part of an internal company hackathon, and I learned a lot doing so. In this case, we see that generative AI is being used as a helper to add titles and descriptions to panels and dashboards. So it's a great example of a small assist that can reduce some toil and quickly add real value, but it's not necessarily a game changer, right? It helps engineers a small hurdle. But actually adding these descriptions and titles, we found most users don't do this, and it can really help make your dashboards more robust and consumable. So it does have some value there. So here's some code. It's a small behind-the-scenes look of the dashboard assistant. This code is open source. It's in the Grafana repo. And to that point I just made earlier, because we interact with the large language model with natural language, this code is actually pretty easy and straightforward to understand. So here we're looking at the prompt that we're providing to LLM to generate a panel title. And we can see that we're using the panel JSON and the dashboard metadata as helpful context to drive a reasonable answer. And you can see at the top here we have the standard prompt, and we are trying to set the tone for what the LLM should be talking about and what they should return. So a review of this feature, it's useful but by no means groundbreaking. And we need to provide more context and potentially invest into fine-tuning a specialized model to go after some bigger ideas in the dashboard assistant space, such as maybe even generating a useful panel and dashboard from scratch just with a prompt and not just the title and description of that dashboard or panel. So before we move on to the next GenAI feature, I want to intro a metaphor using some song lyrics. And this is the first line. This is a song by Lyle Lovett. And you'll have to trust me, there's a reason for this detour. So if I had a boat, I'd go out on the ocean. Also, I'm not going to sing it. If I had a boat, I'd go out on the ocean. It's a nice vision, right? And if I had a pony, any of you expecting that? It's like something an LLM would write. I'd ride him on my boat. All right. So what I love about the sequence is on line 1, the boat's a dream. It's an if. And by line 4, it's like so real that we're writing a pony on it. All right? So to the metaphor, the ocean is kind of your observability data, and the pony is AI, especially generative AI, which benefits from more structure and context, which is your boat. So for both machine learning and GenAI, you need to answer the question of what to train on. You need to figure out what patterns to recognize and what to compare those patterns to. The notion of this random signal has changed its pattern is rarely useful without any context, like who needs to know this? But if we have both structures in place, we can do great things. So where else can LLMs add value in the observability space? What about helping users write queries? We tried using LLMs to jumpstart a more challenging task, like writing PromQL. PromQL stands for Prometheus Query Language, and Prometheus is just an open source metrics database. For this feature, we built a vector model based on thousands of open source PromQL queries. We then access that model alongside an LLM to allow users to write more effective queries. So let's take a little bit closer look at what's going on behind the scenes with the Query Advisor. First, we start with the system prompt. What does system mean in this case? Well, it's just there's 3 different roles of OpenAI's chat API: system, user, and assistant. The system provides the high-level instructions and guidelines. The user presents the queries or prompts, and the assistant is a response from the LLM. In the Query Advisor system prompts case, we're providing a policy down here to not make up label names. As you can imagine, if we did not have this, it was free. It was doing whatever it wanted to do. So here we can see the generation of the user persona prompt. In a nutshell, we're asking the LLM to pick and choose relevant PromQL templates found via the semantic search based on the context of the user's input. So I want to zoom in a little bit further on how we retrieve these templates. So here we can see Grafana's LLM plugin at work. So we actually have like a vector tie-in with this plugin that you can connect a vector database to. The PromQL templates are stored in a vector database filled with thousands of open source PromQL templates. We then use the LLM plugin to semantically search, in this case return the top 5 results based on the user's input. So then here on the bottom right, we pass these results as a user persona prompt, and then ask the LLM like which one of these is the best fit based on the user's intent. So what was the result of this? It was actually not as positive. We did not get great feedback on this feature. There's potential with it, and we might pick it back up again with better tech, but this time the development is paused and it stopped in private preview. Some of the key challenges that we ran into was that the user needs to know what metric they want to investigate in the first place, and that's not always clear. You also need a library of examples for this vector database to be effective, and having that metadata is not very easy to source and it takes time. It's also, the results were not always reliable. It sometimes returned broken PromQL, and hallucinations could definitely be a real pain. To the addition to this, this is kind of in a vacuum. Like the user has no way of knowing the result that's being returned is actually a valid or good result. So it lacks the ability for the user to be able to check the result of the LLM easily in context. So large language models, right, are kind of a black box, and they can be challenging to achieve. It can be challenging to achieve deterministic high-quality results consistently. One technique here, just kind of stepping away a little bit, that you can try to enforce more deterministic results in OpenAI's API is modifying the temperature property. You can modify this down to 0 if you really want to try to get as deterministic as possible. There's a similar property in other LLMs as well. So increasing the temperature leads to more varied and creative outputs. And the reasoning behind this temperature property and what's doing behind the scenes is that it controls the required threshold of confidence here on the right, 97%, required for the next token generated by the LLM. So with a higher temperature, you're basically lowering the confidence threshold so more things can come through. While at a low temperature, like 0, it'll only enforce that the most probable next word will be used. So in this example, we have cat sat on A, and Matt is said to be like 97% the next word. Let's say we had a higher temperature where it's very creative, and maybe you choose hat, which would be like 60% in this case. So with the PromQL Query Advisor, we didn't have enough structure to provide the necessary context for it to be consistently useful for novice users. And in this case, actually increasing the determinism was not useful either. And to improve this feature, we'd most likely need to train our own specialized model for the PromQL context, basically building a much better boat. But there's still potential here. But at the same time, we have limited resources, and have to be opportunistic with what use cases we target. It's also fair to point out that not all experiences have to be AI-driven. For example, is there a way that we could avoid the need for users to even understand PromPtQL in the first place? So here's an example of what we're doing instead. It's called Explore Metrics. Basically delivering a curated view of the metrics you have without you needing to learn a new query language. We're currently running experiences to decide interesting metrics to highlight via change point detection or anomalies from seasonality of your data. Explore Logs is even cooler because our AI ML team at Grafana have been in collaboration with this team to help with their pattern detection. And this is a huge step also of writing LogQL from scratch. Logs, it's low-key. LogQL is how you query logs in Loki, which is an open source database for logs. So the thing that's cool about this is that you can still get the query in the end, the LogQL query in the end, that you can use that to create alerts or something, but you don't have to do this from scratch and understand another query language. All right, so finally, profiling. Profiling enables deep debugging and optimization of performance, and it can uncover resource issues at the code level. But it's not really easy to read the results. There's a ton of info packed in there, and you maybe didn't write the code or have the context or know your way around it that well. So we collected all the context we have in this flame graph here and passed it to an LLM to summarize and suggest contributing causes for any bottlenecks or errors in the profile. And the result of this has been very successful. The thing that's key here is that the context we're able to pass to it, the flame graph profile, includes a lot of context that we can, and we can send all this context to the LLM. There's also the added confidence, right? Where the user can get these results and then look at the flame graph right next to the results. So kind of have a human check, right? To actually know if the large language model is just making something up. Where we can make this feature better is to guide users to find the profiles they care about and also kind of know when to add profiles into their data. So I think we have enough time. I can do a couple of little bonus stories. So sweet. So AI can also add value to internal operations as well. It doesn't just have to be something you build that's future facing. So one of the problems that we have in maintaining a large open source project is that keeping up with incoming issues and triaging those incoming issues can be a challenge from the community. It can feel a little overwhelming. Hopefully this guy doesn't show up in your nightmares. And even with a dedicated team, these issues can languish. So what triaging an issue basically means adding a label to it so it gets directed to the right team inside the company. So an engineer actually tackled this problem, leveraging large language models, and so far we've seen great results. We reduced the incoming backlog from a steady lag of around 300 issues down to 0. And there's also already a case where we're able to catch an incident early on due to a community member reporting it and the issue being routed automatically to the right people. So this was accomplished through training a specialized model and running a custom GitHub action that interacts with these models when a new issue is added to the open source repo. And I highly suggest that you check out the open source GitHub repo for more details on how this works. It's this Grafana auto triager. And a final bonus, what about monitoring your own LLM features? We recently launched a solution in Grafana Cloud to address this, and it's powered by OpenLIT, which is an open source SDK that's similar to OpenTelemetry, but specialized around AI. With this, you can get insights such as performance monitoring of the underlying LLM, cost optimization, and end-to-end tracing of requests. It's also giving you the ability to monitor your prompt and generate responses. So all this can come together and help you answer questions like, how many LLM requests are being made? Is the feature stable and responding quickly to users? If you rewrite your prompts, can you tell if the new version is better? And how much is this feature costing you? And more specifically, how much is each request costing you? So go to the question that we started today on. How does AI intersect with observability? So on the one hand, it's just another technology. It doesn't really change anything unless we can genuinely alter the value that people get from it. It does change many layers, though. You need to filter and build better context, like we're able to do with the flame graph profiles. And you need to guide humans to achieve good results through opinionated teaching user interfaces. There's also the need to understand that observability in other industries have very diverse users and workflows. There's different people from novice to experts, from new hires to founding engineers, and these users have different needs at different times. There's sometimes a time where you're rushing to stop a fire, and there's other times where you're carefully fine-tuning your monitoring setup. And it's also important to mention here, don't forget the internal users and the operational side of your own company. How can these tools benefit your day-to-day work life? So regarding where we see working with AI in this observability industry, we want to empower people and not replace them. We want to improve the skills that people do need, which is grasping clearly the set of full moving parts, service dependencies, and what's healthy or not for their system, and automate the skills that people don't really need, which is things like memorizing context. So there's a lot of unknowns still ahead with this space, and lots of new pathways open, though some are bad and potentially dead ends. We saw this with the PromQL Query Advisor example, where an alternative solution may be a better value, which is not even using large language models in the first place. Not every problem needs this ChatGPT hammer. That being said, we learned a lot in building that Query Advisor. So we need to be open to prototyping, collecting feedback, and pivoting, using real value add as a North Star in our use cases of AI. Thank you all for your time.